This is part two of the linear programming chapter, and I thought that I'll show you a little bit about how to proceed with the graph and with the inequality. Let's start here. So we had this equation with the equal sign, and one way, if you were to use Excel, you don't need to at this point. One way to use Excel would be to get the graph done for you on Excel. So if this is my equation, I've kept 12y on the left, I've moved 5x to the right, hence minus 5x plus 2400, and then I've divided by 12 throughout. uh, 12y divided by 12, and this and so on and so forth. So this is basically the same as this one, and again the reason I've tried to come up with this equation is because it might be easier for me to do that on Excel. So I can start with x equal to 0, and and if I substitute 0 here in x, so 0 times the bracket will give me 0 plus 200. I will get 200 here. Now you can either do this, or you can just let Excel do it for you. And let me just fix my speaker. Right, so I hope you can hear me. So you can let Excel do it for you. So that would basically mean equal to minus 5 over 12 multiplied by x. I would rather put this as well in bracket, plus 200, and that should give me 200, which we discussed in a few minutes back, right? And I can increment the x. Let's increase it by 0.5. Sorry, let's increase this by 0.5 just to get a few values, and so on. And we can drag this down, and we can drag this down, and we can get a graph. And think I've left a mistake here. Yeah, I forgot the minus sign. Right, so there you go. And I keep going on. I think increasing by 0.5 is a bit tedious. Let's increase by 1 then. Oh, it's going to take a while to touch the x-axis, so let's increment by 5. Right, by 5. Let's see what happens. No, that's still going to take a lot of time for me to reach the x-axis, so that's a lot of time. Let's see what it gets. Right, assembly at 450x. Right, okay, so we can just increase by, let's say, 50, just to keep it short, right? And there you go. So there you go. So as you can see, I don't need these values because I'm getting y negative here. It wouldn't make too much sense. And I can plot, let's remove these two. I can plot this, and I will get the assembly line. Yeah, there you go. So that would be one way to do it on Excel. Remember, at this point of time, you don't need Excel, you just need two coordinates. If I were doing the job, I would choose x equal to 0, substitute here, get y, and I would put y equal to 0 here or here, and get x, which would be 480. Yeah, 480. Here I can just increase this by 30, and I should get 0 here. So we can just plot the graph. Let's do that again. So instead of incrementing by 30, let's increment by 50, let's increment by 30, and you should see something a little bit more interesting. There you go. There. Just for the sake of simplicity, I've decided to end to stop it here because I do get the 0 here. So if I plot this, right, yeah, there you go. Remember, we do not need the negative x and the negative y for obvious reason. Now, what I was saying earlier, and please do follow here for those who are not too familiar with inequality. What I was saying here, I'm looking at the assembly line with the equal sign, and that's the line here. Now, do remember, I don't need the equal sign. I need the, oh dear, I've closed it. I need the inequality here. So I need the inequality which is less than or less than equal to in this case, right? So what I was saying in part 1 is with the inequality, it can either be here or be here, and I don't want you to guess. I don't want you to learn anything by heart. It's so simple. All you have to do is do some testing. We can just take any coordinate on one side. So you can take anything here or here and test whether that coordinate satisfies 5x plus 12y less than equal to, I'm just going to write it this way, 2400. So this is what I want to test with a coordinate. Doesn't matter which coordinate you take, here or here, and see whether it's satisfying this inequality. The easiest coordinate is 0 0. I can see it. I don't need to find anything. You could have taken 100 comma 50, you could have taken 200 comma 100, doesn't matter where, but usually I take the easiest one which is visible to me, which is 0 0 here, and 0 0 being on this side of the line. And let me repeat, I could have taken any coordinate, the result will be the same. So let's take the easiest coordinate, which is 0 0, and it's on this side of the line here. So if I put 0 0 here, substituting x with 0 and y 0, I would get 5 times 0. I'm just writing the result here. 5 times 0 plus 12 times 0, and indeed the answer is less than, in this case, less than equal to 2400, because on the left side I have 0 being less than or equal to 2400. So I know for a fact that 0 0 will satisfy this inequality. It's a fact. You could take a coordinate there and substitute. You will see that it doesn't satisfy this inequality. So if I had taken, let's say, 500 comma 250, which is around here, 500 on the x, 250 on the y, it's around here. If I substitute in x and y, I bet that I will get it as greater than equal to, well, at least not less than equal to 2400. Hence, this area is not what I want because it did not satisfy the inequality. And this is the area I want because it just satisfied the inequality when I chose one point out of millions here. I've chosen, for me, the easiest 100. I've substituted it. It does make sense. Hence, this is my region, my required region for this inequality. So what you do next is up to you. I know Mauritian students, they've been told that they have to shade the unwanted region. So you would shade this region. This is the unwanted region because 0 0 is here. That's the wanted region which satisfies this inequality. So you usually, if you're doing that with pen, paper, graph paper, pencil, you would shade the unwanted region because you want to keep the required, the wanted region clean and tidy, because that's where the work is going to be later. You don't want to mess up this wanted region here. You want to show me that the inequality satisfies this region, so you will shade the unwanted region. That's if you are doing with pen and paper. If you are doing it on a graph, it doesn't matter. You can shade whatever you want. So if I go here and I show you, right? So this is what we just did was for assembly. You could do that for the other two constraints, finishing and spraying, and you will get 3 lines, and you would choose 1/3 and 1/3. Now, because this graph can be done on Excel, what we are showing you here is the 1/3 region here. We decided here on Excel to shade the 1/3. So my recommendation, if you're doing it with pen, paper, graph paper, pencil, whatever, shade the unwanted. Keep the 1/3 region clean, nice and tidy. If you're doing it on Excel or on PowerPoint, whatever Word, Microsoft Word, you can shade the 1/3 region. So take your time, maybe take a graph paper and try to get these 3 lines, and whatever we did for assembly by testing a coordinate, whether it satisfies the inequality. And if you're doing on graph paper, you shade the unwanted. So what I would see is you shading this side, and you would end up with a nice clean and tidy space here, right? So don't get confused why you will be shading that side and I'm shading this side. I'm not using pen and paper. I'm just doing a diagram on Excel and showing it to you. So this piece here, this space here, is the space which I got with the 3 or 5 rather. Remember, I have an inequality with assembly, one with finishing, one with spray, and one with the x-axis being greater than or equal to 0, one with the y-axis being greater than or equal to 0. With the 5 inequalities, I end up with this space here, right? So do it with a paper or on a graph paper and see for yourself that this is indeed the required region. So this dot here, 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 and here. So this is my required, if I have to use the proper term, this is my feasible region. And let me tell you that my answer, which is maximizing the profit, will either be, and I'm not going to tell you, I'm just going to take all the coordinates, all the possibilities here, will either be here, or here, or here, or here, or here. Trust me, you don't need to waste your time on any coordinates in the space here. So if I have to repeat what I just said, find your feasible region and find the intersection in the feasible region. So this is an intersection of the x-axis and y-axis. This is an intersection of the finishing line and the y-axis. This is an intersection of the assembly and the finishing. This is an intersection of the assembly and the spraying. This is the intersection of sorry, where am I? The x-axis and the spraying. And out of these 5 intersections, your profit, your maximum profit, will be on one of those 5. And if you think about it, you can kind of reject one straight away. You can reject the 0, 0. Don't worry too much about it. If you didn't see the obvious reason, don't worry. I'm sure it will come to you in a few minutes. So what should we do now is just the obvious, which is let's find those coordinates 1, 2, 3, 4, and 5. Now, out of these 5, I think 3 are quite easy to get, and I'm not talking about you looking on the graph paper. I'm just asking you to use your mathematics to get these 3 intersections. Now, this one is obvious. 0, 0 is the one intersection. This one is the equation of the finishing line intersecting the y-axis. So if you have this equation, all you have to do is put x equal to 0 and you should get this coordinate here. For this coordinate, it's the intersection of, sorry, let me just see, intersection of spraying with the x-axis. So if you have the spraying equation, which you do, you can just put y equal to 0 and you'll get this coordinate. So 3 coordinates are pretty much obvious. Let me just see if we have it here. Yeah, this coordinate, there's a 5th one, the 0, 0, it hasn't been given to you, it hasn't been written, but we can consider it. So this coordinate, and the 0, 0 are the three easy coordinates because they are easy to find. Now, what about B and C? What's B and C here would be this one and this one, right? So B and C, that's your mathematics. That's where your mathematics come in with solving simultaneous equation. So if you take your equation of line for, let me just see this. So for assembly intersecting with finishing, your simultaneous solving the simultaneous equation will give you coordinate B. If you solve simultaneously between assembly and spring, that will give you coordinate C. Now, if you're familiar with solving simultaneous equation, it should not be a problem. If you're not, then I would advise you to practice a little bit of your simultaneous equation. There are four methods, at least four methods to solve simultaneous equation. One is by substituting, second is by elimination, third is using graph, fourth is using matrices. Well, graph, if you have a graph paper, you can find the point of intersection. It might be easy, it might be tough to read, doesn't well, we have a kind of limitation here with the graph. Don't worry about the method called matrix method. It's not worth it. It's going to be a bit tedious, but I'm pretty sure sometime before your university life you would have come across simultaneous equation use and solving them using either elimination process or substitution process. So please try to solve simultaneous equation using these two pairs of lines to get these two coordinates here. Right, so this is one homework that I'm expecting you to do, and so I'm asking you to solve simultaneously. Where is it? Simultaneously assembly against spray, assembly against finishing, assembly against spray, finishing against spraying. One of them is not needed here because we had only 2 points of intersection. So find them. I can't remember which one it was, so I don't think finishing was one of them. Uh, Question is, did you need the graph to really uh, get to the final answer? Answer is no. So the graph helps for you to see, and but if you reach this particular slide and you want to avoid the graph, what I would do is, obviously by default zero is there. I would see where this line touches the x-axis and the y-axis, this one x-axis and the y-axis as well for this one, and then I would look for the point of intersection between these two lines and these two lines. So I would probably have a set of coordinates, more than 5 actually, and then I would do whatever comes next to get to the maximum profit. So what I'm trying to say here is you don't need to wait for the graph and see. You can just start doing the simultaneous equation here using these lines. And so practice this. I would expect some students to come in and tell me that they don't know how to solve simultaneous equation. So that's fine. And then when we meet, we can try a couple of examples. We can try these examples. It's tough for me to show you the method of substitution and elimination right now on Microsoft Word. It's going to be quite complicated. But so please, if you do remember, if you've done it before, you might want to practice. And the solution is going to be here. So these would be the 2 points of intersection we're going to get here. Sorry. Right? Remember, there's a fifth one, 0 coordinate. So if these are the coordinates small x and small y, what I can do is substitute the x and y in my profit equation and get the profit. So substituting 0 in x and 0 in y, sorry, 160 in y, I will get this profit. And substituting these two values, which I've just got you by solving simultaneous equation, I would get this profit, and so on and so forth. If I have 0 here, clearly I would substitute 0 and 0 in x and y, 0 and 0 here, and I will get profit 0, which is way less than these numbers. That's why I said earlier, one obvious coordinate that you can reject straight away would be the 0, 0. So out of all these profit, which one is maximum? It's this one, as you can see. And the coordinates that's giving me the maximum profit is coordinate B. That's where the maximum profit is happening. To summarize, I can say I need, remember what is small x and what is small y? The number of items for the number of bins and the number of bowls that I have to manufacture to give me the maximum profit. Hence, I would manufacture 184.6 bins, 123.1 bowls to give me the maximum profit. Obviously, it doesn't quite make sense to produce 184.6 bins and 123.1 bowls. That's some other discussion. In terms of mathematics and in terms of numbers, I think we have our answer here. Please practice your simultaneous equations and how to solve them, either by elimination or by substitution, for you to get these two coordinates here. That's basically the first big chunk of the work's done, where we've just maximized the profit and we've found how many of product capital letter X, or bins if you want, or how many product of capital letter Y, bowls if you want, that we need to produce to manufacture, with £30 profit per product capital X, £100 profit per product capital Y, to give me £17,846.15, which is the maximum profit. So that's the first big job that you can do, right? So this is the I think that was coordinate. Let me just see. That was coordinate B. That's where the maximum profit is happening. Good. Right. What we want to do now is talk a little bit about this one, which is another point of intersection which has not been considered to find our solution, for obvious reason, because my feasible region was on this boundary here, and that coordinate here was not part of my feasible region. That's why I did not consider this point of intersection. So what does it mean? What's the implication here is something we want to discuss. Right? So remember, how did we get B? We got B by solving the assembly equation with the finishing equation, right? So that's the coordinate, that's the number of items for X and Y. And if I substitute these two coordinates in okay, I have to go back. So if I substitute these two coordinates in assembly and finishing, these two being the point of the two lines forming the point of intersection. So if I substitute the pair of numbers here, the coordinates, in my equation, here, assembly and finishing, if I substitute those two numbers here, I will get exactly 2,400 for assembly, and I will get exactly 800 for finishing. Again, for obvious reason, because I've just used these two lines to come up with those coordinates. So if I take those coordinates, I substitute in the X and the Y, I should get exactly 2,400 and 800 respectively. And that's what we've shown you here. Right? So finishing and assembly, if I substitute these two in those two equations, I would get the exact numbers, which means I've used whatever my boss gave me as a span of time for me to finish the job and to do the assembly. I've used every single hours given to me. So my boss gave me 800 hours and I've used them all, because these two coordinates fits in the equation to give me 100. I've used them all. Similarly for assembly, if you substitute these two coordinates in the assembly equation, you would get exactly 2400. But what if you substitute these two coordinates in the, look at this coordinate, look at this point of intersection here. This is between spraying and finishing. So if I put this coordinate in spraying, you would see that you get another value, which is in this case 10,046.2. And if I move back, oh, it's here, the time allocated to me by my boss was 1200. So all I needed was 10,046.2 hours, but my boss gave me some extra time. So I have some spare time left. For spring, it was completely 153.8 hours were completely useless. My boss gave me extra time, 153.8 hours extra. So that's the meaning of this point of intersection, which we didn't consider and which involved spraying. And that tells you the spare hours that I was given to do the job, and I did it in less than the amount of time allocated to me. Now, what comes next is your lab work, and couple of things I need to discuss here, but I think it's pretty much obvious. So, if you do your lab work, this is the output you're gonna get in Excel. This is the assembly line. This is the number of hours you will eventually use. So you've used all, we saw earlier. For finishing, you've used all, you were given 800, you've used all your 800. And for spraying, you were given 1200, and you've used only this much. We got this value earlier. Here it is. Sorry, here it is. So we got this. So that's Excel job. So it's just telling me by looking at this column here, this is the value that is new to me. These two were seen before. This is new to me. So I knew this spraying time allocated to me was too much. I've only needed 1046, and the extra is the 153 spare hours that I had. There you go. Here. So in Excel, you can get all these values that we've got using graph paper, pen, calculations, simultaneous equation. We can get those answers here and here. So slack means remaining time, the spare time. So clearly you won't have any time left if you've used all of them. Whereas here, like I've said, we've discussed this value before. Now we have this column, which is extremely important in terms of terminology. Now, assembly and finishing were the point of intersection to give me this maximum profit, the coordinates to give me the maximum profit. So those two lines are known as the binding, those two constraints are known as the binding constraints. So to summarize, the binding constraints are the constraints which when intersect with one another, when intersecting with one another, will give me the maximum profit. Clearly, assembly and finishing will be the binding constraints, and the remaining one will be the non-binding, which means I did not have to use this line to find the maximum profit. So you need to get this slide clear in your head. What are binding constraints? They are the constraints which eventually intersected to give me the maximum profit. What's the non-binding constraint? Is the constraint where we do have some slack, some spare hours when we did the job of spraying, right? So this is something you want to do on Excel. For your test, we can give you this output and we can ask you to explain certain values here. So I'll let you do the lab work to come up with this. I think I've done the explanation here. Right, so another output here is this. Now I'm gonna stop the video here because again it's getting too big, and I will talk about sensitivity analysis in part 3 of our lecture. So I'm breaking it down. I don't know how many parts there will be. I don't think it's going to go beyond part 3. We are already on slide 34 out of 44. I reckon that the last 10 slides, 11 slides can be done in third part. So I'll see you in a bit. How do we stop this? So